All right, solutions to assignment number 22, the review assignment. Now, you should always try this first, right? And then see if you did it right. So, during what? First of all, what is this? This is the velocity and time in minutes of a bug that's moving along a vertical piece, so going up or down. So, what does velocity tell you? How fast it's going and what direction it's going. So, during what interval is the bug moving down? Negative. So, when is the velocity negative? So, the answer is from 0 to 4, it's below. We can answer it right here. Oops, right here. Next question, looking off the graph. Can you do calculus off a graph? During what intervals is the bug resting? That's when the velocity is equal to 0. So at 0, from 4 to 8 and 20. That's when it's resting, when the velocity is 0. During what interval is the bug's acceleration positive? So when we're looking at velocity, to know if the acceleration is positive, we're looking for a positive slope. So not here, so positive slope. So that right here, the acceleration is positive. So from 2 to 4. Where else do we have it? From 8 to 14, and that's it. We're looking for that positive slope for positive acceleration. Integrate from 0 to 20. So if I integrate, I'm finding the area. So I have a triangle. I know that's negative, and another triangle, and I know that's positive. I'll start with the positive one. So half the base times the height. So 8 to 20, that's 12. So half the base times the height, which is 6. Subtract half the base, 4, and 4 for the height. If you cared to simplify it, this would be 36 take away 8. That answer is 28. Then the question is, assuming the bug started its journey at 40 inches on that vertical thing, where did the bug end its journey? So it started at 40. From 0 to 20, it gained. So it went down and then up. But overall, the net gain was 28. So altogether, that answer is it ended its journey at 68 inches. F. This means all the areas are positive. So instead of subtracting, everything becomes positive. So it's 36 plus 8. That's 44. Using correct units, explain the meaning of the integral from part F. So the total distance, that's what it means. The total distance the bug traveled, and I'm losing juice on this pen. Let's try this one. The total distance the bug traveled, looks a little better, was 44 inches. That's up and down, counting all of the distance as a positive value. Find the average velocity of the bug. So for this one, we'll do over here, it's integrating from 0 to 20. Find the average value divided by 20. So we already did this work above. That answer was 28 divided by 20, and that's inches per minute. So on average, that's how fast it was going. Find the average acceleration of the bug over the interval from 0 to 20. So for this one, let's try it again. So to find average value, integrate from 0 to 20, and you integrate the acceleration. Now, when you integrate the acceleration, it becomes the velocity from 0 to 20. So we could have done this at the beginning. It's the y2 minus y1, same answer, divided by 20. So y2 minus y1, we could have done that at the beginning, over x2 minus x1. And then look off the velocity at 20 is 0. The velocity at 0 is 0. So the average velocity is 0. Or average acceleration is 0. And that would be in, what's the units? Inches per minute squared. Done. Turn the page. This might require a little more writing, so I'm going to do that. So I'm going to switch. So review assignment number 22. So you're given the velocity is t squared minus 4 over t cubed. You're allowed to use a calculator here, in that the initial position is 0, not the initial position, is 0 when t equals 1. So when t equals 1, the position is 0. And it says write an expression for the acceleration of that. So to find the acceleration, we need to take the derivative twice. So if you're allowed to use a calculator, might as well, right? Use it. That's a t at the bottom there. So acceleration is just the derivative of that. So I don't know what here. I'll just practice the rule. The bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. I'll write an expression for the position of the particle at any time. So the position at any time, the starting position is 0, and we would integrate from 1 to whatever we needed to, whatever that time was, and we'd integrate the velocity for that. And that would give me the position at any time. Now, what would it look like if I actually integrated it? Leave it at that. So part C. For what values does the particle change direction? So if we take this, it changes direction. We need to know when it's equal to 0. So just the numerator. So if we solve this and square root it, the answer is positive and negative 2. Now, the t is always greater than 1, so really the only number is positive 2. There are no, in the question it says that t is greater than or equal to 1, so only positive 2. Then into the velocity, if I plugged in a number bigger than 2, like 3, it would be positive, but if I plugged in like 1/2, it would be negative, so it changes direction at t equals 2. Part D. During what interval is the acceleration positive? So when I take the derivative, when is that derivative positive? So I want to use my calculator here. So I'm going to graph this. If I have something there, I need to erase it just to have a clean slate. And my window is going to go from like 1 to something. This is way too much. Okay, so I changed the window so I can kind of see it. And then I'm going to do that for acceleration. It's the derivative of the velocity. So I'm going to press I'm going to press the button right beside the 9. I'm going to press the derivative button and then control divide. I'm going to type that in, x squared instead of, oops, what did I do? So try it again. So I'm going to go control divide. So we have x squared subtract 4 over x cubed. And I want to see what the graph looks like. So I can kind of see in terms of where the acceleration's positive compared to negative in terms of the derivative. I need to look at it really carefully here, right? Let me change that window. See if I can see it. So I see it crosses right there, right? So it's positive and then it crosses. So I want to find where the 0 is. And I'm going to say, oh, okay, so from 0 to 3.464, the acceleration is above. It's positive. So from 1 to 464, by looking off the graph, you can see it's above and not below there. So where is the acceleration positive? I graphed it and see where it's above. And then I used the calculator to find where the value is. E. Find the average velocity from 1 to e squared. So there's the formula for average velocity, and then subtract the bounce. Just type that in your calculator with what the velocity is. And you should get 0.006. Try it with your calculator. See if that gives you 0.006. Part F. Find the total distance. Well, total distance from where to where? From 1 to e squared. Total distance is the absolute value of velocity. So put the absolute value bars there, divided by the difference of the bounds. No, not even difference, because we're not finding that. So just the total distance is the absolute value of the velocity, not the average value. So just the total distance, the absolute value bars, and type it in, and you should get the answer 1.650. Try it with your calculator. Do you know where the absolute value bars is? So you know how to integrate and where E is. If you press this button beside the 9, then you can get the bars right there. So highlight over those bars and press enter, and then you'll be able to get it. H. Find the limit. This is an end behavior question. So the bottom is more powerful than the top for the right end behavior, so that answer is 0. When you integrate, we can also see if our calculator can do the work for us too. So do you know where the limit button is? So if I go menu calculus limit, I can use any letter. So I can use T to infinity. Infinity is where the pi button is, so press pi and then find infinity. And then I'm going to integrate. See if this works. I hope this works. T squared over, subtract 4 over t cubed. And you get both for infinity for both. So one is 0 and the other one is infinity, or it doesn't exist. But you know what? Your calculator did all the work for you, so that was nice. All right, number 3, calculator is allowed. Let R be the region bounded by two functions, 2 cosine x, and the second function is g at x equals 1/2 x, and the y-axis. So without a calculator, this is what it would look like. So it would start at 2, and then 1/2 x would start at 0. And so you have this line, and then you have this curve, right, that kind of goes like this and then continues. And then the y-axis, so that you have a graph that kind of looks like this. And it says find the, shade it, which I did. You know what the cosine wave looks like, and then the line. And we sketched it and shaded it, and then set up an integral for the area of that. So I need to know where those 2 points intersect. So I'm going to put them both in my calculator. Sometimes I get frustrated with the camera and the shine on the calculator, but I'm going to deal with it. So the first one is just 2 cosine x, and the second one is 1/2. I'll change the x, and then I'm going to go menu. I'm just going to do a standard view, see if that's good enough so I don't have to do anything else. That's number 5. And then ultimately I just want to know in the first quadrant where they cross. So where the red and blue cross, so I'm going to go menu, analyze, intersection, and then to the left, and then to the right, and then it's going to highlight over it, and I get 1.252. So 1.252. So we're going to integrate from 0 to that. Top, subtract bottom. That's 2 cosine x, subtract 1/2 x. Top, subtract bottom. There's your bounds. And you get, use your calculator. I think it was 3a. Sketch the graph. I did that. Set up an integral. I did that. Oh, I didn't. Oh, so I'm not even like solving for it. So I'd already set up the integral. That's part. This is A. This is B. Part C. Set up an integral for the volume whose base and cross sections cut picture are squares to the x. So we know the formula for the area of a square is base squared, and base is top subtract bottom. So I'm going to integrate 1.252, 2 cosine x subtract 1/2 x squared dx. So that's going to give me the volume using squares. So that's the formula, and the base is top subtract bottom. I plug it in, I have my answer. Part D, set up a volume when it's revolved around the x-axis. So when I go around the x, there's a space. Revolving is a circle. The bounds didn't change. There's a big radius and a small radius. So the big radius, top, subtract bottom, which is 0. And then the small radius, which is top, subtract bottom, which is 0. I don't need to subtract 0, but there's the setup of top, subtract bottom for the big radius and the small radius. E, set up an integral formed when it's revolved around the line y equals -2. So that's down here somewhere, -2. So again, it's going to be a circle, top, subtract bottom. So it's 2 cosine x, subtract -2. When you subtract a negative, you're adding if you like. And then 1/2 x, subtract -2. Again, you're adding if you like. And you have the 2 setups for that. Part F. Set up an integral for the sum for when the r is revolved about the line y equals k, and k is bigger than 2. So if k is bigger than 2, it's up here is where k is. It's above that. So again, top, subtract bottom. Now it'll be the line. So again, we're integrating. Top, subtract. So top is k, subtract the bottom, which is 1/2 x. Subtract. Top, which is k, subtract the bottom, which now is the curve. And then you have the setup. G, find the actual area of R. So go back to part B. This is what I was going to do at the beginning. And actually find that area. And it's 1.507. You should always try with your calculator. Make sure you know how to use your calculator, not just copy my video. H, suppose C is a constant such that the vertical line x equals c divides the region into regions of equal area. So we have this, right? So we're going to go 0 to some x value. So if you look here on the graph, we want to find some k value that splits this in half where both areas are exactly the same. So it's going to go from 0 to k. I don't know what that k is. And I'm going to go top subtract bottom. So 2 cosine x subtract 1/2 x. And it's going to be equal to this answer divided by 2. And then I would just use my calculator. I would solve and get my answer. Let's see if we can do this together. Why not? So how would that be? So let's go back to this. Go menu algebra solve. And we're going to integrate from 0 to k. And it's 2 cosine x subtract 1/2 x dx equals, and on the other side is 1.507 divided by 2, comma k, and see if it'll solve it for me. I hope so. So I get two answers, 0.408 or 2.03. So it has to be before, the bound is 1.252, right? So it can't be past, it has to be in between those two numbers. So the only answer that could be is 0.408. All right, number 3. I just did number 3. Number 4. No calculator allowed. Here's our last one for review today. So there's a function. It's called an even function. So it's symmetric around the y. And f at x and the derivative of f at x both exist on the open interval from -4 to 0, which means not the ends, but in the middle it exists. The graph of the derivative is shown to the right. This is only a portion of the whole thing. So find all values of x from here to here at which f at x has a relative maximum. That's when we go positive to negative. So we know it's at 1. Why? And it changes, right? From positive to negative at x equals 1. Okay. B. Find all values as a relative minimum. Well, that's when it goes from negative to positive, so it's at 3. Same idea, right? The derivative changes. This time from negative to positive at x equals 3. Find the x-coordinate of each point of inflection and justify your answer. So for the derivative, the point of inflection is where it changes from increasing to decreasing or vice versa. In other words, it's the turning point, so at 2. In this case, it changes from decreasing to increasing. So we're looking at the derivative changing from decreasing to increasing. Now suppose you actually have function values equals 1. Could you graph f at x? Let me do it down here. Why not? So what are the numbers we have? It equals 1. So, we got -4. I didn't put this axis in a very good spot. But I can figure it out. 1, 2, 3. So at -4, it's 1. At 0, it's 1. And at 4, it's 1. It wants to test you whether you understand that it's an even function. So we'll first start here, and then we'll reflect it over. So this function increases, and then at 1. And because the derivative is decreasing, it's concave down. It continues to be concave down to 2. So it continues to be concave down to 2. So this whole time it's decreasing. Maybe it's better if I do number lines so you can really see with the number line. So if I did a first derivative number line, the only numbers that I would care about are 1 and 3. And this is from 0 to 4. It's above, then it's below and above. So that means it's going to increase, and then it's going to decrease, and then it's going to increase. And then the second derivative has to do with increasing and decreasing. So if I look at the graph, this decreases to 2. And then increases after 2. So that means concave down and concave up. And then I got to put all the pieces together. So at 3, somewhere down here, this changes to concave up. And then this exact same. So if I make sure it matches. So it increases, then it decreases, then it increases. It's concave down, and then it's concave up. And then I just reflect that over. And then I have an even looking function because it's symmetric around the y-axis. I got more questions to answer. E, at what x value does the absolute maximum occur? And so when I look at this graph, you can see the absolute maximum would occur at 1. Suppose the table indicates f at x for selected values. Use the trapezoidal rule to approximate the integration of that. So we start with 1/2, 4 subintervals. Here they are. So if I use 4 of them, 0 to 1, 1 to 2, 2 to 3, 3 to 4, so each width would be 1. And then the first height, and then you double the next height, and then you double the next height, and then you double the next height, which is 0, and then the last height is 1. So there's the trapezoidal rule. For G, use a Riemann sum using the midpoint of 4. So we don't have the 1/2 in front for that. Just 1. And midpoint means we use the middle height, so that's 1.6. Use the middle height, 1.6. Use the middle height, 0.3. And use the middle height, again, 0.3. And you did it. And then part H, approximate -4 to 4 using your answers above. So you would do is just double the answer because it's even. So you would just double the answers, this is saying. So whatever answers these is you would just double it and it would give you that. That's it, right? We're done, right? Mr. G Math over and out. I'm proud of you for getting your work done and working with me and trying first and then looking at the video. Keep asking me questions and don't give up, all right? Until next time.